everyone and welcome to the WebGrade Tutor. Before we dive into today's problem, let's quick look at the structure of ATAR Mathematical Application Exam of 2024. So you know how exactly what you are preparing for. Basically, this exam has the two sections. The section 1 is a calculator-free paper and the section 2 is the calculator paper with 5 questions in the section 1 with 54 mark and with 8 questions and 99 mark. So the total percentage you got on here for the first one, that is 35%, and the for second one, that's the 65%, and the both of the 100% on here. So you are go to the channel to expert at our maths help. We break down the real exam question on here. You can see this is the calculator free paper with 35% for 54 mark on this one. And this question is 2024 exam. This is the question number 1 you can see on here. Okay, let's look at the statement. A school is hosting a sport carnival to raise funds for charity. The first event is 400-meter running race between a year 8 student and year 12 student. The year 12 student will start at the starting line and expected to run the speed at 8 meters per second. The year 8 student will start 100-meter IH of the starting line and expected to run at the speed of 6 meters per second. Let and represented the number of the second after the start of the race. First of all, you have just need to be understand the problem on here. Basically, a school is hosting a sport carnival to raise this fund. This information gave us the total race, which is 400 meter on here. And that is between the two students, the year 8 12 student and the year 8 student. So the student speed and starting points are given. We can just see that the year 12 student will start at the starting line with 8 meters per second of the speed, which means that year 12 student starting from 0 meter and runs at 8 meters per second. So same as it is on this one, the year 8 student will start 100-meter IH and of the starting line is expected 6 meters per second. So which means that year 8 students start with the 100-meter and run slow with 6 meters per second. So we just need to be checked that also given the time variable on here that give us let and represented the number of the second after the start of the race, which means that n is basically on here the time in second. So look at the part A. Write a recursive rule to model the total distance in meter the year 12 student in form of starting line during the race. In this part A, we asked to write a recursive rule for the year 12 student. Basically, first of all, you have need to be understand what's the recursive rule. A recursive rule tells us how a sequence change step by step. We can make a recursive rule or the recursive formula by using the two steps. We will write the first starting value. Then we can apply the rule to go from one step to the next. So let's start understanding their motions on here. The year 12 student, the starting line of the year 12 student, it's from the 0 second and they are 0 meter at 0 second. They run at the constant speed of 8 meters per second. So now let's build the recursive rule step by step. First, we're defining the starting position that was 0. So distance of the year 12 student at 0 meter, that is 0 meter per second. Also, then we define the change for each step. We are working for the year 12 student. So the distance for year 12 student on the nth time second, that is equals to the d12 into n minus 1 plus 8. So this tells us the distance at time n equal to the previous distance d12 into n minus 1 plus 8 more meters in this one. So let's look at the pattern using this rule. We can work on the pattern as well. If you can just see this one, if I am taking that for nth term, the n is taking as in time in second and the distance in meters on here. So if you are taking the d12 at 0, that's mean if you are taking n as 0 second, at 1 second, at 2 second, at 3 second, where will be the year 12 student at in the second, that how much distance that will cover. So when we are taking that d12 they at 0, that's already the first term which is equals to the 0. And if we are talking about the next, if I'm taking d12 as it is distance 12 and is 1, then obviously the next number is d12 and minus 1, which will makes that d into 12, 1 minus 1, and the next term that is 8 plus 8. So which means that d12 1 minus 1 that is d12 into 1, the first series, that is equals to the d12 of 0 plus 8. We already get the value of d12 of 0, which is 0 on here, so we can just replace this one by 0. So now we can just take it like as D12. Instead of this position, I can write 0 plus 8. That is equals to the 8. Now the next term for 2 second. So I can replace n by 2. Here's the n. So D12 into 2. That is equals to the D12 into 2 minus 1, which will equals to the 1. Basically, 2 minus 1 is 1 plus 8. Now you can observe that we already get the value of D12 1. That is 8 on here. We can replace this one by 8 and then plus 8. So you can just write it like as 8 plus 8. That is equals to the 16. So which means that 8 is the pattern on here. We can add 8 in the previous number for getting the new number. For getting that was the 2 second. Now for 3 second, for 4 second, and for 5 second, we can just take it like as 16 plus 8 in the previous one. That will be the 24, and then 24 plus 8, that will be 32, and then 32 plus 8, that will be the 40 on here. So we can see that after 5 seconds, the year 12 student has to run 40 meter. This is the meaning of 8 times 5. We can also take that the 8 times of 5, which is equals to the 40. And it's just a shortcut to get the fifth term of the pattern. So basically in the part 2, you can observe they are saying, deduce the rule of nth term of the model in the total distance in meter of the year 8 student in form of starting line during the race. So first of all, you have just need to be, what we will find in this one, we want to find the direct formula, also called the nth term rule. That is the nth term rule for the direct formula. For year 8 student. The year 8 student start with the 100 meter. We already work on here. The year 8 student, that is start with the 100 meter and run slow with the 6 meter per second. That is in given situation. So we can just take it like as the two situation. The year 8 students start at the 100 meter. They run at 6 meter per second. So instead to build it step by step, it's make a formula that goes straight to the answer at any second n. We can write for the year 8, D8, that is for n, which is equals to the 100 plus 6n. That's mean at 0 time, they are at 100 meter. At every second, they move 6 more meter, which means that at 1 second, we can just write it for the 1 second, that would be, we can replace n by 1, and we can just write in form of 100 plus 6 into 1. That will make 106. And at the 2 second, we can just replace it by 2. So 100, 6 times 2, 12. 100 plus 12, that will be for the second term, that will be 112 for n equals to 2 for 2 seconds. Okay. Now, look at the B part of the situation. In this part, they are asking determine how many meters the year 8 student is ahead of the year 12 student after 5 seconds. So basically, in this part, we have just need to work how far ahead the year 8 student after 5 seconds. So we need to find how many meters that year 8 student is ahead for 12 student after 5 seconds. Let's calculate each student position after 5 seconds. I was working with the nth term with the 5 second of this series. You can also work for the 6 second, for the 7 second, for the 8 second. But here we are going with the 5 seconds. So the 5 second answer, that was 8 times 5, that is equals to the 40. So when we are talking about the year 12 student after the 5 second, we can just take it like 8 times 5, that is equals to the 40 on here. We can just write it 40 meter. And same as it is for the year 8 student, that is in the form of after 5 seconds, that is also the 100 plus 6 times 5. We are just replacing n in the D8 series for the year 8. So that will be equals to the 3 times 5, 6 times 5, 30, 30 plus 100, 130 meter. Now we find the difference between these two values. That will make 130 meter. Take away 40 meter. That is equals to the 90 meter. So after 5 seconds, the year 8 student is 90 meter ahead of the year 12 student. Now let's talk about the part C. Before that one, you can just need to be understand after 30 seconds, the year 8 student trips over. The result is 5 second delay for the year 8 student. That's mean the year 8 student trips after 30 seconds and has a 5 second delay. What's happening in this situation? We are being told that after 30 seconds, the year 8 student trip and stop running for 5 seconds. That's mean the year 8 student will stand still for 5 seconds, but the year 12 student keep running at their usual speed. Now we need to figure out after 5 second delay, how much a lead does the year 8 student still have, if any. So basically look at the statement. They are asking determine how much a lead that year 8 student will have after 5 second delay. So look at this one. That's mean we have just need to be calculate for the both student have run in 30 seconds. The year 12 student runs 8 meter per second. So which means that we can just take it for the year 12 after 30 seconds first of all. Then we can easily determine for the 5 second delay. So year 12 student For the 30 second, that's 8 times 30. That will equals to the 240 meter. And the year 8 students start 100 meter ahead and run at 6 meter per second. So the distance on here, that is equals to after 30 second for year 8, that is 100 plus 6 times 30. That will make 100 plus 180, which is equals to the 280 meter. So at the 30 second mark, the year 12 is at 240 meter and year 8 is at 280 meter. That means for the 5 second, the year 8 stay at 280 meter and year 12 keep running 8 meter per second. So the distance year 12 in 5 second that we was already getting. For the 5 second, the distance was on here. You can observe that is 40 meter. And he's keep going running. So we can just take it like as 240 on here for the 30 second and plus 5 more. That will be the new position for the 240 meter plus 40 meter. So now the final after the 30 second, that will be the 280 meter. So year 12 keep running at 8 meter per second. So that's mean we just need to be know the both student are the same place 280 meter. After the 5 second delay, the year student has no lead left. That's mean the year 12 student catch up completely during that delay. Okay. So now look at the D part of this one. Determine who wins the race. Justify your answer. So what's happening in this one? Now we have to figure out who reached the finish line at 400 meter first. We calculate how long it take each student to get 400 meter and compare it with the time. So basically, let's see who win the race. The first part is time for year 12 to finish. They run at 8 meter per second. We know that if they run at 8 meter per second, we can say that there's a total race is 400 and the year 12 student run for the 8n, which means that 8 meter per second. So we can just calculate easily, find the value of n on here by dividing both sides by 8. We can just take it like as 400 by 8 and 8 by 8 for ending the 8 with the variable. So 8 cancel with this 8 and then we can just strike this one 8 times 5 40 and 0 as it is. So the value of n is on here, which is 50 by cancelling these two situations. Okay, so the year 12 student finished the race in 50 seconds and we just need to be get it like that. Step 2, time for the year 8 to finish. So they started at 100 meter and run 6 meter per second, which means that we can just take it for the next number, that will be the 400. For the nth term, that is 100 plus 6n. So we can take away this 600. This is adding on here, while taking on the other side, that will be taking away, converting into the negative. So 400 take away 100, that's just 6n will left after the equal. So you can just say like 300 equals to the 6n. And then 6 is multiplying by n on here. After switching the 6 on the other side, that will be converted into the division. So 300 divided by 6, that is equals to the n. When you will divide both of the term, that like you just need to check that 6 times 530 and 0 as it is. So the value of n is on here, that will be the 50. You can observe. This also means the year 8 student should finish in 50 seconds. But remember, the one part is very important for remembrance on here. Basically, they had 5 second delay after tripping. So actual time taken, that is 50 plus 5. Because of the 5 minute delay, 50 plus 5, that is equals to the 55 second. So the year 12 student finished the race in 50 seconds and year 8 student finished the race in 55 seconds. So we can just write it like on here, 55 seconds. Who is the faster? Basically, year 12 student finish in 50 seconds and year 8 student finish in 55 seconds. So the year 12 student wins the race by the 5 seconds. So your final answer will be the year 12 students win the race because the finish 5 seconds faster due to the year 8 student delay. Thank you.